Gravity facts. Apart from the fact that everything falls at a speed of 9.8 meters per square second, what else do we know about gravity? These gravity facts will tell you all about what this force does for us, as well as what will happen without it. Planets are weighed by scientists using their gravitational pull. You might be wondering how we can measure objects in space, much less objects with the mass of planets, when it seems impossible. But after Lord Henry Cavendish's experiment in 1797, everything was different. As a result of his discoveries, scientists can now determine a planet's weight by measuring the time it takes for objects to orbit it and the distance at which they are located from the planet. With two 150-kilogram lead balls, planets, and two smaller spheres, Cavendish set up an experiment, moons. Cavendish's experiment revealed the value of g, the quantity that connects the gravitational force between two bodies to their masses and distances, which was the final piece of Newton's gravitational puzzle. Cavendish was the first person to attempt weighing a planet using the new value of g. He arrived at the figure of 6 billion trillion tons for the mass of the Earth using Newton's equation and the value of g. A refrigerator magnet is less powerful than gravity. A magnet the size of a dime can withstand the gravitational pull of the Earth and adhere to objects when it is placed on a refrigerator. Weight and gravity are not the same thing. One of the overlooked facts about gravity is that although the force of gravity in space is 90% of the force an astronaut experiences on Earth, astronauts don't have weight in space. We experience weight as a force on a surface, like on a chair or a bed. Astronauts are, therefore, weightless in space. Through the Tower of Pisa, Galileo Galilei demonstrated that gravitational acceleration is constant. In the 14th century, the Italian scientist Galileo Galilei dropped two spheres with different masses from the Leaning Tower of Pisa. He did this to show how their mass had no impact on the time of descent and that they all fell at the same time. Galileo discovered that the objects fell with the same acceleration, according to his student Viviani. He thus refuted Aristotle's earlier theory of the acceleration of gravity, which holds that objects fall at rates based on their mass. Acceleration changes your weight. Running puts strain on your body because gravity is pulling you toward the center of the Earth, but the ground you are running on pushes up and precisely balances this force. What makes you feel heavy is the interaction of forces. On a roller coaster, as you speed up to the top, the chair pushes harder against your body, defying gravity and making you feel heavier. Your body feels lighter, though, once the roller coaster begins to accelerate downward. This is why, as you descend, you briefly feel weightless. These oblique changes in weight are referred to as g-force. Some bacteria thrive at low gravity. For interesting gravity information, bacteria developed in a NASA space shuttle formed bonds and took on shapes not previously observed in nature, allowing them to survive at much higher densities. When compared to identical bacteria on Earth, this behavior is entirely different. Dark energy opposes the pull of gravity. Because gravity is a weak force, the universe cannot be held together by it. The universe has been expanding since the Big Bang. The pull of gravity in the universe is being opposed by dark energy. Dark energy is thought to be evenly distributed, accelerating the expansion of the universe and preventing gravity from pulling everything back together. Gravity is only powerful over short distances. The gravitational field has no bounds. Even though gravity has an infinite range, it may be the weakest of the four fundamental forces. Although its reach is theoretically limitless, its strength rapidly decreases as objects are separated from one another. Artificial gravity is produced by spinning motions. The outer walls of a spinning fair ride offer an inward, center-seeking force that keeps riders rotating in a circle. The sensation of constant momentum is known as centripetal force, and it has a gravitational-like sensation. On Mars, you are almost 3 times lighter than you are on Earth. Your body is made up of a fixed number of atoms, and as a result, mass is a fixed property. Your mass remains constant regardless of where you are, on Earth, in outer space, or on the Moon. However, other planets' gravitational pull is different from Earth's. As a result, even though your mass is the same, your weight is not. On planes, astronauts train for spaceflight. Apart from outer space, the sky is the closest thing we have to defying gravity. To simulate a brief period of weightlessness, planes make a parabolic arc, which allows astronauts to practice for space travel. Gravitationally bound system of the Sun and the asteroids that orbit it is known as the Solar System. A massive interstellar molecular cloud gravitationally collapsed to form it 4.6 billion years ago. The Sun contains 99.86% of the system's mass, with Jupiter holding the majority of the remaining mass. Mercury, Venus, Earth, and Mars are the 4 terrestrial planets in the inner solar system, and they are made primarily of rock and metal. The 4 massive planets in the outer solar system dwarf the terrestrial planets in both size and mass. The next 2, Uranus and Neptune, are ice giants, being primarily composed of volatile substances with relatively high melting points compared to hydrogen and helium, such as water, ammonia, and methane. Jupiter and Saturn, the 2 largest, are gas giants, being primarily composed of hydrogen and helium. The solar system will disintegrate in the absence of gravity. Without gravity, planets and moons would stop rotating around their parent bodies and start to drift apart. However, the Sun has a worse fate because it would explode in a matter of minutes if there was no gravity in the solar system. There's constant pressure on the Sun. Due to its immense size, its core is compressed by gravity and becomes hot enough to burn hydrogen. The Sun is in equilibrium thanks to gravity and radiation pressure. Without gravity, there would be nothing to counteract the tremendous pressure that is currently building inside the Sun's core. The Sun's chemical processes will be disrupted by the sudden loss of gravity, and it will release extremely hot gas throughout the solar system. That's for now. We appreciate you for being here. View more our channel videos.